Welcome back to this video series of C++ programming. This is the lecture 18 of this video series, and today we are going to discuss about the one of the important topic of C++ programming, and that is copy constructor. Copy constructor is one of the form of a constructor overloading. Let's see some of the important point of copy constructor. Defining a copy constructor can help you to prevent problems that might occur when one object is used to initialize another. That means when you're trying to initialize one object to another, especially in the scenario of dynamic memory allocation, then the copy constructor are very useful. The object initialization occurs in the following three scenarios. When one object explicitly initializes another, such as in declaration. Second, when a copy of an object is made to be passed to a function, that means object is passed to a function through a call by value mechanism. And the third, when a temporary object is generated, most commonly as a return value, that means when you are returning the object from a function. The copy constructor is useful in the first scenario, that is when one object explicitly initializes another object, that is the declaration. We'll talk about these important points with the help of an example. We'll see an example where we'll create our dynamic memory for the array, and we'll first create one object, and when we initialize the object through a constructor, we'll initialize that dynamic memory, which is actually the array, the dynamically allocated array, and then we will create another object, and we will initialize that another object with the previously created object. So it looks confusing at this time, but let's understand with the help of an example. So first I will create one class. I will call this as array, and inside this create some private data members. One is this pointer variable, which will point to the dynamically allocated memory location or dynamically allocated array, and then another variable. This will act as the size of that array, and insert this we'll create some public members, and that is precisely a constructor. So here in this main function, we'll create one array object of this array, and we'll initialize this object with some value. In this case, I'm initializing this object value as a 10. So this is basically, this will govern the size of this array, which is we are going to create dynamically. Now when we are initializing something to this object, we must create a constructor that must be a parameterized constructor. So here I will create one constructor and specify the parameters. So we'll call this as a sz, that is size. And now inside this constructor, we'll allocate the memory to the integer array, which is of this pass parameter size, and this is happening dynamically with the help of this new operator. And now this p variable is pointing to the memory location which is allocated. Now we must handle the errors that was written by the errors. Here I will add one statement, and if there is null pointer is not written, that means the memory is allocated successfully, and if it is allocated successfully, then we can resume the normal operation. Here first thing I want to do is to initialize this size variable. This is a member variable with this passed value sz, and that is used for the let purpose. I will create one for loop here. This for loop will iterate this sz number of times. Now in this case the value we are passing is a 10, so this loop will iterate for the 10 number of times. And what we want to do is we want to initialize this dynamically allocated memory to which this p variable pointer is pointing with some data. And here we initialize this value as this I plus 1. So we'll initialize the values 1 to 10 in this memory block which is allocated dynamically. Now in this case, how we initializing is using this p variable and then index to this variable. So now this is equivalent to writing this statement. So this p is the base pointer, and then every time we are incrementing it by this index I. So it will point to the next memory location. and then this star asterisk mark, which is outside these two brackets, actually dereferencing that pointer. So that means we are storing this value into this memory location, which is uh, which is created by this p plus I address. All right, and I will add one more function here that will display the contents of this dynamically allocated array. So here again, I have to use the for loop, and then help of cout object will display the content of this array. So again, we are dereferencing in the similar manner. All right, now let's run the program, and here it must be size. Now let run the program, and let's see what does it output. So here we must call this display function here, otherwise it won't display the data. So now it is displaying the values as 1 to 10, as we are initializing at this place, that is in this constructor. Now let's understand the second part of this program, that is the initialization. For that purpose, I will create one more object of the same class, and I will call this as object 1. And inside this, I will do the initialization in this way. So what it is doing, it is actually initializing this object 1 with the content of this object. And this initialization is happening the bit by bit manner. So all the members of object 1 will be initialized with all the members, content of all the members of the object. And now if I call this function again, and if I try to print the output, for that let me print the next line here. If I run the program and print the output, then it will print the same value 2 times. Now let's understand about this initialization here. When you are initializing this object 1 with the object on the same line, it is not calling the constructor function. The constructor function is called only in the case of this object. But when you are initializing, the constructor function is not called. The compiler by default copy the content of this object into this object 1 without the call of this constructor. Let's see with the help of a debugging. So I will put a breakpoint here, and I will run the program. Now it is halted. If I step into the program now, it will call this constructor function, and now inside this constructor function it will do the dynamic memory allocation and then array initialization things. So this is how it is happening for this first object. Now if I run the program and put breakpoint here, now you can see the first 10 values are printed. Next time for this object, if I step into a code, you can see the constructor function is not called. That means the compiler has copied the content from this object 1 into the object into the object 1 without the calling constructor. And then, so what is happening in this case? This p is a pointer variable which is pointing to the some memory which is allocated dynamically. And when you do the copy operation from one object to another, or the initialization of one object to another, the p variable which is pointing to the another object, that is object 1, will now point to the same memory which is allocated previously using this constructor. So I'll repeat, this p variable, which is now the p variable, first of all, the p variable will be created separately for the object 1 and object, the two different objects. But now, when you create the first object through the with the help of constructor, we are allocating the dynamic memory. And now this p, which is belongs to the object, uh, which is belong to this object here, will point to that dynamically allocated memory. Next time when you do initialization, the p variable which belongs to the that object obj1 will again point to the same memory location. That means there is no separate memory is allocated for both the objects, and that is the problem here. That is the problem of this initialization. Both the variables are pointing to the same memory location. Now let's create the real problem here. So what I will do here is I will add this statement, and this is deleting this p object. So this is actually freeing the memory which was allocated previously by using this statement. So p was pointing to the memory location which was allocated dynamically, and now with the help of this statement, we are freeing that memory. And I'm calling this statement after this display function. So once this display function is called and it printed the values, I'm deleting this p object or the p variable. Now if I, in this case, if I try to run the program, let's see what happens. Now this some exception is thrown and system is crashed. And if you see output here, first 10 values are printed, but the second this value, some garbage data is printed. Let's understand the reason behind this. The reason is, in the first case, when we deleted that the dynamically allocated memory, in the second case, as we talked, when we do initialization, the p variable belongs to this obj1 object, was still pointing to that memory location which was allocated previously. And now, before coming here, after this display function, we just freed that memory or we destroyed that memory. But this p variable of the obj1 still pointing to that old memory location which is not actually available, and that's the reason it is printing some garbage values. So this is the issue of object initialization, and that happens especially in case of a dynamic memory allocation. So how to solve this issue? This issue is solved with the help of a constructor function, a copy constructor function. So here we'll create one more copy constructor function. To create a copy constructor function, you have to specify this constant keyword after the name of that constructor. Now here the name of the copy constructor is same as that of another normal constructor, and that becomes now a constructor overloading. But the parameters are different. So this constant keyword followed with the name of that class and then the reference to a object. So this is object name, and we are creating a reference to an object. Now this is acting as an implicit pointer to this object obj. And here what we'll do here with the help of this object, now this is the size variable. The size variable, it is belonging to this old object, that is obj, because we are passing this obj here, and here we are collecting as a reference. So here where the size is belongs to that obj object. So size is stored when we created the constructor function, or when we call the constructor function for the first object obj. And with that size we are allocating some memory dynamically. That means now the memory will be allocated of the equal size. Here we'll again initialize the size member variable, this time for the another object obj1 with the size of this obj object. In this case, we'll again initialize this uh, memory, and this time with a different value. with the I plus 2. So when you create this object, it will invoke this copy constructor function, and inside this it will create the it will allocate the memory dynamically, and the p will now point to the different memory location, not to the previous memory location of this obj1 object. All right, so now let's compile the program and let's see what does it outputs. And you can see it is outputting the first 10 values from 1 to 10 and the second values from 2 to 2, 3, 4, 5 in that manner. So because we have added here the offset of a 2. We have understood how the copy constructor are working, but here we have done one mistake. Our intention is to copy one object from the content of one object into another. In this case, the content of obj1 into this ob1 object. But here, instead rather than copying the original content, we have copied the new content. So we must copy here the original contents. That means we here should use this statement. And after writing this statement, it will actually initialize this two objects, copy the content of this one into this another object. But now when you do that, this delete operation should not be added, or delete statement should not be added here, because if you add here after this statement, your the original allocated memory will be deleted, and when you are trying to initialize that the previously allocated memory to this new allocated memory, this memory is actually not available. So it will get some garbage value into this new allocated memory. So let's see exactly what does it do. If I run this program, you can see it is printing the second value as some garbage value. The good thing is my system is not crashed this time even with the delete statement, because the memory is still valid. But in order to serve our purpose, we must not use this delete statement here. That's great. So our program is working fine. So I hope now you have understood the concept of copy constructor and where exactly the copy constructor is utilized. Remember, the copy constructor is utilized when you are initializing one object to another object, and in the scenarios where you are dynamically allocated memory and freeing it actually before initialization. So in this case, the copy constructor are being used. I hope now you have understood the concept of this copy constructor. For now, thanks for watching this video and stay tuned for the next video.